Hey guys, welcome back. Today is day 43 and we're going to learn how to graph systems of equations. You will need a ruler for graphing today, so please make sure you have one. Okay, so we'll start with the warm-up. I'd like it if you'd actually try the warm-up. It is in Schoology. Pause the video and then go over your results. So the one thing you are going to need to know for today is how to graph an equation. So we've done quite a bit of graphing in the second quarter. We start out and we take the equation and we put it into slope-intercept form. So remember, slope-intercept form is y is equal to mx plus b. All right, so I'm just going to start by subtracting my 3x from both sides, and I end up with negative 2y rather, equals negative 3x plus 10. And then when I divide both sides by negative 2, I find my equation is y is equal to 3/2 x minus 5. Okay, once I'm in that form, I can easily identify my slope, which is 3/2, and my y-intercept, which is negative 5. So to graph the warm-up here, we're going to start with the y-intercept of negative 5. We're going to plot that point, and then we're going to use the slope, which is 3/2. We're going to think of our rise over our run. We're going to rise 3, and then we're going to run 2. So there's our second point, and I'll do another one. There we go. All right, we then have our points. We connect them, and there's our line. Okay, so the second question states whether the ordered pair is a solution to the equation. So all you have to do is take this ordered pair, okay, and plug it in. So if you notice with number 1, this line is actually an infinite number of ordered pairs. Each one is a solution, okay, as long as it's on the line. So to see if an ordered pair is on the line, you simply plug in the values for your x and your y. So your x is 0 minus 2 times your y is negative 2 equals 6. So this becomes 0 plus 4. And let's see, does 4? No, 4 does not equal 6. So this is no. That ordered pair would not be on the line. All right, now we're going backwards and we're looking at a graph and we're coming up with the equation. So the first thing I do is I look for the y-intercept. In this case, the y-intercept is 3. All right, and then I want to identify another point that we're crossing, so I'll use this one. All right, so from this point, I can say I rise 2 and I run to the left 1 or negative 1. So my slope here is going to be a negative 2. All right, once I have the slope and the y-intercept, it's easy to put it together. Y is equal to negative 2x plus 3. All right, and then number 4 says, is the ordered pair a solution to the above linear equation? All right, well, this is easy enough. All I have to do is look at the point 0, 0. Is it on the line? No, it's not, so no, it's not a solution. Okay, you could also plug it in and say, put in the point 0, 0 here, and you would get 0 is equal to 2 times 0, which is 0, 3, and it's not. Okay, but it's easier just to look at the graph and see that it's not on the line. All right, so that leads us into solving systems by graphing. Okay, a system of equations is 2 or more equations with the same variables. So we're only going to be working with 2 equations. Okay, the solution to a system of equations is the ordered pair that satisfies both equations. And there's 3 possible solutions to a system of equations. So the 3 solutions would be just one possible solution, and that would be where the 2 lines intersect. Okay, if you have an ordered pair that satisfies both, it's actually going to be at the point that the 2 lines cross. Okay, so that's when we have one solution. There's no solution if the 2 lines never intersect, and that would happen because they're parallel. And we've learned that they would parallel. We know they're parallel because they have the same slope. So we know that they would never cross, therefore there is no solution. And then the third scenario is when there's infinite solutions, and that would happen when your 2 lines happen to be the same line. Okay, once you put them in slope-intercept form, you realize they're both the same line. They're right on top of each other. That means there would be an infinite number of points that would be overlapping or intersecting. Okay, so the steps to solve a linear system would be to graph both equations on the same coordinate plane. And to simplify the graphing, we like to put it in slope-intercept form, just like we did in the warm-up. And then we kind of estimate the coordinates of the point of intersection, okay? So this method of graphing really only works when it's nice and simple and the intersecting point happens to be right at a whole number ordered pair, okay? It is only the first of 3 methods that we're going to learn. Okay, and then we need to do a check step to check the coordinates to substitute them into the equation to make sure they work. Okay, so this will make more sense with some examples. So we start out with our first system of equations, and sometimes with the system you'll actually see this little bracket around them. Okay, you might see that like on a standardized test. All that means is just kind of a notation that these are the two equations we're using in our system. So I like to first identify my slope. This one's easy because we're already in slope-intercept form. So to graph this line, we've got our b is 1, y-intercept is 1, and our slope is 1. So this is where it's important that you have a ruler, okay? And it's kind of hard for me because I can't use one with that. I'm going to try to make straight lines. Okay, so there's my first line. My second line, okay, if I look at it, my slope is going to be -1 and my y-intercept is 3. So to graph it, I start at 3 and then, oops, that's a weird graph thing that came out of nowhere. Okay. All right, so now my slope is -1, and right there, boom, I can see where I intersect. I go over that blue line, okay? So it's going to look like this. Okay, so that intersecting point, the ordered pair, in this case is at 1, 2. All right, notice it's 1 is my x and 2 is my y. So the ordered pair or the solution is 1, 2. All right, I can check that then by taking the 1, 2 and plugging it into both of these equations. And I'll do that down here. So my y is 2. Does that equal 1 plus 1? Yep, that works. And the second one, my y is 2. Does that equal, well, it's -x, so -1 plus 3, and that one works. So I did my check step, and I can verify that it works. All right, so moving on, we're going to try, and you might want to try number 2 on your own, and you can, because they're both in slope-intercept form. Okay, but I'll go ahead and identify the slope and the y-intercept. 1, 2, 3, 4. Okay, my slope is 1. So when I graph this line, it's positive slope. Okay. Now I'm going to do that second line. My slope is 2, and my y-intercept is 5. So I'm going to get that point right there. And in this case, my slope is going to be 2. So I'm going to go down 2 and over 1, or up 2 and over 1, 2, there we go. So there it is. All right, so I actually crossed right there at -1, 3. All right, so that's my solution, the intersecting point where the two lines intersect. Okay, so when I do my check step, I'm going to plug in my y, I'm going to plug it into the two equations. So y equals x plus 4. My y is 3. Does that equal, all right, my x? Okay, so it's going to be equal to -1 and 3. Okay, so I've got, oops, my y. Made a mistake there. So the check step should be y, which is 3. Does that equal -1 plus 4? Yes, it does. And the second check step, all right, my y is 3. Does that equal 2 times -1 plus 5? So that's -2 plus 5, and that does equal 3. So it works for both of those. Okay, so our examples are not always going to be in slope-intercept form, so we do have to put them into slope-intercept form. So we're going to follow the golden rule of algebra. We're going to subtract x from both sides. So in this case, y is going to be equal to -x plus 5. Again, we identify our slope as -1, y-intercept is 5. Okay, so we've got 1, 2, 3, 4, 5, and our slope is -1. Okay, so when we do that, we make our line. All right, now the second one, I'm going to bring the 2x to the other side. So y is, let's do that in red. All right, so y is going to be equal to -2x plus 8. So we get up here at 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our y-intercept, and now since our slope is going to be a -2, so let's write that down. Our slope is -2, and our y-intercept is 8. Okay, so in this case, we're going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. So right there is actually where we cross. Okay, we draw our line. and it looks like it's at 1, 2, 3, 1, 2. So we're at 3, 2. That would be the solution. Okay. Again, we're going to do our check step. We're going to plug the values in. So we get, and again, we plug them into the two equations. X plus y equals 5. So 3 plus 2, does that equal 5? Yep. And then we've got 2 times our x, which is 2 times 3 plus 2. Does that equal 8? And in that case, that would be 6 plus 2. And yes, that does equal 8. So our check step worked. Okay. All right, so for purposes of time and trying to keep the video not too long, I'm going to jump right to problems number 7 and 8. But I want you to pause the video and try 4, 5, and 6 and go out to the key on Schoology, because in all of these examples, you're going to have to put them into Slope-Intercept Form, okay? And check the examples with the key that is in Schoology, okay? So these were all examples of having one solution, all right? Now we jump to number 7, okay? So number 7, when we graph number 7, we'll start with our slope is 2 and our y-intercept is 3. So I'm going to graph this, okay? And my slope is 2 over 1, up 2, over 1, or down 2 to the left 1, okay? So I have my first line, all right? Now the second line, I'm going to bring the 4x to the other side, so 2y equals 4x minus 8. Then I divide by 2, and I end up with y is equal to 2x minus 4. Okay, so when I have my 2x minus 4, I've got, start at my y-intercept. My slope is 2, and my y-intercept is negative 4. So I'm going to go down here, 1, 2, 3, 4, and then my slope is 2. Okay, so what you can see here is an example of two lines that will never intersect, okay? And they'll never intersect because, look, they have the same slope. And if they have the same slope, we know they're parallel. Parallel lines never intersect. So there's no point, there's no solution, okay? It's a simple answer. There will be no solution. Okay. Now, number 8, when we do number 8, we solve for y. We put it into slope-intercept form. We get negative y is negative 3x minus 3. When we divide by negative 1, we get y is 3x plus 3. Okay, so when we have our y is equal to 3x plus 3, or actually negative 3, oops, let me see. Did I do that? That's 3x plus 3. Let me see what I did here. Yep, there it is. Okay, so I just want to make sure that that's positive. Okay. All right, so we're going to graph this first one. So we start at the y-intercept of 3, and our slope is 3. 1, 2, 3, and over 1. 1, 2, 3, and over 1. All right, so, or we could go down 3 and over 1. All right. There we go. So there's our line. That's the first one. All right, now when I do the second one, I end up with negative 2y is equal to negative 6x minus 6. And then when I divide both sides by the negative 2, we end up with y is equal to 3x plus 3. Notice these are both the same equation, okay? So when I graph the second line, it's going to be right on top of the first line, and every single point is going to intersect. So this is an example of infinite solutions. There's an infinite number of solutions, okay? Because this line goes on and on forever. All right, so same slope, but different y-intercept. We know they're parallel. That's example 7 and 8. When they're both the same line, infinite solutions. Okay, so looking at number 9, it says a solution to a system of equations is the ordered pair that satisfies both equations. So this is like doing the check step. The question says, is 0, negative 2 a solution to the following system of equations? So we just plug in 0 and negative 2, and we get 0 minus 2 times negative 2. Does that equal 4? Well, 4 does equal 4, so this one's yes, but you've got to do it with both, okay? It's going to be true for both. So now I have my y, which is negative 2, minus my x, which is 0. Does that equal negative 2? Well, that one does too, okay? So this is an example of yes, it does satisfy it, okay? Number 10 is choose 6 a solution to the following system of equations. When I plug it in, again, my y is 6 minus 6 is equal to 3 times my x, which is 2, minus 3. Well, 6, and then I've got 6 minus 3. So 6 does not equal 3, or negative 3 rather. So this is a no, or 6 equal 3 rather. So this is a no. Does not equal it because it doesn't work out. 6 does not equal 3. All right, and we don't need to go on. As soon as you get a no, you know it's going to be no because it, but we can try it anyway. And it doesn't matter even if the second one worked, it has to be true for both. So in this case, 6 is equal to 2 times 2, and 6 does not equal 4. Okay, so we have a no and a no. Either way, it's going to be a no. All right, now the last example says, what is the solution to the following system of equations? This is the easiest type of problem. You just need to look at the graph and identify where the two lines intersect. You don't need to figure out the equations of the line. You don't need to make it more complicated. They intersect at 1, 3. Okay, so that's it. I would say go ahead and try the homework. All right. The other thing that you can do is actually put this system of equations to kind of check your work out. You can look at Desmos. All right. Let me see if I have Desmos up here. Here's an example of putting them both in. All right. So if we wanted to, I have an example here. I'll pull it into the screen where I took the two equations in Desmos and I put them in, and I could see that the intersecting point is right there at 3, 6. Okay, so another good way to check it, but you do need to know how to do this work by hand. Okay, bye-bye.